Let's start section 1.6. We're going to talk about other types of equations. We've already studied linear equations and quadratic equations, and now we have several more to look at. The first in our list is rational equations, and so let's get right to it. So what is a rational equation? Well, remember, a rational number is a number that can be written as a fraction. And so a rational equation should have fractions in it. And specifically, a rational equation has a fraction where the variable is in the denominator. So variable is in the denominator of a fraction. And so, of course, the first thing that we need to be able to do is to recognize that we have a rational equation. When we look at this first example here, we see the variable x here in the denominator, and so we know that's rational. There are three key points that we want to keep in mind as we work through these examples. The first one is that we want to identify the domain of the equation. Identify the domain of the equation. And I'll talk about that in just a minute. And then the second thing that we want to do is we want to clear the fractions. We want to get rid of the fractions so that we wind up with an equation that's either linear or quadratic. And so how do we clear the fractions? Well, we did this earlier in the chapter, and the way we did it was we multiply by the least common denominator. And so we'll talk about that in just a minute. And the last thing that we want to keep in mind when we work through these is that we should always be sure that our solution is actually in the domain of the equation. Be sure your answer is in the domain. Okay, so let's get right into this first example here. We say that we want to identify the domain of the equation. What does that mean? Well, it means what are the possible answers, or what numbers are not possible. What numbers can't be solutions to this equation? And so the key here is to remember that division by 0 is not possible. The denominator can't be 0. The denominator can't be equal to 0. And so this denominator right here says x plus 1. And so x plus 1 cannot be equal to 0. Of course, we don't have to worry about this denominator over here. It's 4, and that's not 0. And this x over on the right is divided by 1, so that denominator is not 0 either. It's the denominator with the variable in it that we have to be concerned about. And so that's this denominator x plus 1. If x plus 1 is not equal to 0, then we can subtract 1 from both sides of that, just like we're solving an equation. And we can say, well, x is not equal to negative 1. So we don't know what x is equal to, but we know for sure that the answer cannot be negative 1. So if you were trying to write the domain in a more formal way, you might write the set of all real numbers except negative 1. That's not necessary at this moment. We just need to know that negative 1 cannot be the answer. And so when we work through the problem, we'll watch out at the end. At the end of the problem, it's possible that we'll calculate that negative 1 is the answer. And so then we'll have to watch out for that. So Anyway, we'll deal with that in a few minutes as well. In the meantime, let's go on now and let's clear the fractions here in the very first step. Let's multiply both sides of the equation by the least common denominator. So over here on the left, you have a factor of 4, and you have a factor of x plus 1, and so the least common denominator would be 4 times x plus 1. And so all we have to do is we just have to multiply both sides of the equation by 4 times x plus 1. Multiplied by 4 times x plus 1 on the right side as well. Okay. And so that could be a little tricky. Maybe we'll go slowly here through this first example and make sure that our multiplication is correct. Sometimes students have trouble with the multiplying fractions and seeing how things cancel. So what we're saying over here on the left is that 4 times x plus 1 has to be multiplied by each term inside the parentheses. First, it has to be multiplied by 4x plus 3 over 4. And notice that the 4's cancel, and we're just left with x plus 1 times 4x plus 3. So maybe we'll just go ahead and write that over here, x plus 1 times 4x plus 3. Notice we cleared out that first fraction. That 4 is gone because it canceled with the 4 that we multiplied by. And so then we also need to multiply 4 times x plus 1 times the next fraction, which is negative 2x over x plus 1. So this time the x plus 1's cancel, and we're left with 4 times negative 2x, or just negative 8x. And then on the other side, nothing cancels. It's just 4 times x plus 1. Nothing cancels because there was no fraction to cancel with. Okay, and so here in this very first step now, we cleared the fractions, and now look at this equation. It's not rational anymore. What kind of equation is it now? It's quadratic. We see it's quadratic when we have this x multiplied by this 4x to make 4x squared. And so we need to multiply out these parentheses on the left and these parentheses on the right, and then we need to go on and simplify and solve from there. So when we multiply x plus 1 times 4x plus 3, we get 4x squared plus 3x plus 4x plus 3, and then there's a minus 8x after that. And then on the right side, we have 4x squared plus 4x. And actually, this is interesting because now we have a 4x squared on the left and a 4x squared on the right. Do you know that they'll cancel? You could write it like this. You could say we're going to subtract 4x squared from both sides, and then they just cancel on both sides. And you could also subtract, well, you have a 4x over here. You'd like to combine it with the other x's on the left. We ought to subtract this 4x to the other side. And of course, when we do that, it cancels with the 4x that was already there. So what are we left with? On the right-hand side, there's just a 0 there. On the left-hand side, you have 3x minus 8x, which is negative 5x. And then you have a plus 3. And so that rational equation got turned into a quadratic equation, and that quadratic equation turned into a linear equation when the x squared terms canceled each other out. So this is all we have left now. We can just subtract 3 from both sides. and then we can divide by -5 on both sides, and our answer will be x equals 3/5. Wonderful. Now, remember there was one more thing we needed to do. We needed to make sure that our answer is in the domain. Remember, the domain just says x can't be -1. Well, since we got 3/5, then that's fine, and we don't have to worry about the domain of the equation in this particular example. You could go on and check the answer by plugging it into the original equation. I won't do that here, just for the sake of time. Okay, let's go on to another one, and actually I think I have about 3 more examples here so that we can get some good practice. So the first thing we wanted to do was identify the domain of the equation. And you know, when you look at this second example here, you might even want to factor the denominator on the right hand side. So let's just go ahead and do that. With enough practice, maybe it won't even be necessary to write it out. But anyway, can you see now for the domain that x minus 2 can't be equal to 0, so x is not positive 2. And then the next denominator, you have x plus 2. That can't be equal to 0. So x is not equal to -2 either. And then over on the right-hand side, you have those same 2 factors. And so we'll get those same 2 answers. 2 and -2 are not in the domain. And so we're done with that. And so we're done with that first part of the problem. The next thing we wanted to do was identify the LCD. And so we need a factor of x minus 2 for this first fraction. And we need a factor of x plus 2 for the next fraction. And then for the last fraction, notice we need those same 2 factors. Well, we already have them here in our LCD, so we don't need to list them again. They're there and they're ready to cancel when we multiply through by that LCD. So let's go ahead and do that. Let's go ahead and multiply both sides of the equation by x minus 2 times x plus 2. Okay. And so can you see when you multiply x minus 2 times x plus 2 times the first term, 3 over x minus 2, the x minus 2's cancel, and you're just left with 3 times x plus 2. 3 times x plus 2. Similarly, when you multiply the LCD times the next term, the x plus 2's are going to cancel, and so you're going to be left with 1 times x minus 2. And then on the right-hand side, the factors x plus 2 and x minus 2 both cancel, and so all we're left with is 12. What kind of equation is this? This is just a linear equation because we only have x to the first power in the equation. We can go ahead and distribute the 3 and get 3x plus 6. And 1 times anything is itself. We didn't really need to write the 1 in the first place right here, but we did, so that's okay. We can simplify now. And then we can go on and finish this. We can combine like terms on the left and get 3x plus x is 4x, and 6 minus 2 is a positive 4, and all that should be equal to 12. And then when we subtract 4 from both sides, we get 4x is equal to 8. And when we divide by 4 on both sides, we get x is equal to 2. Well, wait a second now. Remember one more step. Check if your answer really is in the domain of the equation. And we see that 2 is not possible. If you plug 2 back into the original equation, you get 3 divided by 0, which is not a number, which is not allowed or undefined or not possible. So we're going to have to cross this out, say no, not possible. So what's the answer now? Well, so 2 was the only candidate, 2 was the only possible answer, and it's not possible, so we're left with no answers at all. So we say there's no solution, or the way we learned to write that earlier in the chapter is with the empty set, which we wrote 2 different ways. We could also write out the words no solution. Okay. So, and this shouldn't be too strange. We actually saw an equation earlier in the chapter that didn't have any solutions as well. So this is not the first time we've seen an equation with no solution at all.